Hello everybody. This video or workshop is going to be about Alfred Wegener and his theory of continental drift. So Alfred Wegener was a German scientist, and after a little bit of research in 1912 he proposed a theory that at one time all of Earth's continents were joined, forming one supercontinent. Alfred Wegener even gave the supercontinent a name. He called it Pangaea, which in Greek means all lands. He also gave his theory a name, not right away, but he ended up giving his theory a name, and he called it continental drift. So how did Wegener come up with this? Well, the first thing that Wegener had actually noticed was that he looked at the shape of Africa and he looked at the shape of South America and noticed that this could have sat here at one time. So he thought to himself, all the continents look like pieces of jigsaw puzzles that were once joined together. And then he began looking at gathering evidence to support his thoughts about that supercontinent Pangaea. And he did come across quite a few items. He came across animals as well as plants that can be found on continents across the world, either just along their shorelines or throughout the land. So that was the first piece of evidence that Wegener came across in his quest. Then he also looked at rock layers and rock evidence, or layers of rock evidence, and he could see that there were matching rock layers, and when rock layers lay out, they form in one location. So the only way that you could find identical rock layers across continents is if they were joined together at one point in time and those layers formed at the same location at the same time. So he kept going on the trek for evidence, and he found also that in Antarctica there was evidence of organisms, plant and animal organisms, that could never have lived at the present location in the cold. They were tropical organisms, plants and animal both, that had to have formed near the equator. So that was another good clue to, okay, the continents must have been adjoined at one point in time and must have formed a supercontinent. So before we move any further, you also had done your puzzling of Pangaea. I hope you were successful in that. So we're going to look at how all these pieces of evidence fit together as we puzzle Pangaea. Now I've already completed mine, and you can pause it if you want to look at what we have done. So the instructions tell you to cut out the legend first and color code it according to what you were going to color the individual pieces of evidence. And then you had to line them up so that they actually fit into one supercontinent. So if you color code all the pieces, it definitely makes it easier. I chose these colors just by random choice, so you don't have to go with the same colors I have, but you do need to puzzle Pangaea. So this is kind of what, based on the evidence that Wegener found, you can find ancient mountain ranges, ancient plant types that go across continents. You can find ancient organisms that cross continents, and so forth. So all of these pieces of evidence lead up to what Wegener termed a supercontinent, Pangaea. And this is our model of Pangaea. Now I hope all of you are doing this in your notebook or keeping all your notes together just for your sake, so you can reference them if we have quizzes and such in the future. You'll know where to look if you need additional help. Okay, so we're going to move forward. So this was what Pangaea look like at one point in time, or all lands joined together based on evidence collected from Wegener and other scientists. If you looked at, I had given you this page also, and you can look through this and see if it matches your information of analyzing evidence. So just looking at the different pieces of evidence that were collected over time and that tell us that the continents have shifted in their location over the last 2.5 million years. If you need to pause the video at any time, feel free to do so. Alright, so Wegener did name his supercontinental drift, or Pangaea, and he called the theory, his theory of, yes, the continents have moved over time, he called that theory continental drift. Now, we really don't speak much about continental drift anymore. The current theory to date is called plate tectonics. So, as we move away from Wegener and into further evidence that supports the movement of continents over time, we will no longer refer to this as continental drift. Alfred Wegener was very upfront in discovering evidence that led geologists to move forward. If it wasn't for him laying this foundation, it would have probably taken way longer for the theory of plate tectonics to come out. So we do give him the name Wegener, the father of geology, or the father of plate tectonics. So when he went to New York in 1928 and spoke to the American Association of Petroleum, they are now American Association of Petroleum, and is now referred to as a geologist, so one that studies the earth. He was highly accepted based on his findings of the jigsaw puzzle the continents look like, the plant and animal remains he could locate on different continents, the mountain ranges or the rock layers that coincided on various continents. Where the problem came in wherein Wegener just could not explain his theory. He didn't know how the continents had moved and shifted over time. So he actually said the continents are adrift or drifting like ships on the ocean. So his explanation was continents are just kind of floating on the ocean water and moving around at random. So unfortunately, at that point in time, he truly became the laughing stock of the Geological Society, and he actually never knew anything that happened with his continental drift. Once more evidence was gathered and it moved to the theory of plate tectonics, he was already dead. He died on an expedition to the Arctic. He was coming back from a stroll, actually out there in the Arctic in the freezing weather, and he froze to death. And his body actually remains there. That's a little tidbit for you. So we now know that he was on the right track. He is actually, like we said, the father of the theory of plate tectonics based on all the information that he collected over time. So we do celebrate him now for his achievements. So we're going to end now, and we're going to talk about the new theory that emerges in my next video. Y'all take care and have a good day.